And therefore, I'm very, very pleased to invite here the next moderator and the next set of speakers to come and sit. Lionel Menard from Mines Paritech, and a long-standing member from the GEO community on the data and knowledge working group, as well on the GEO infrastructure. So with this, we'd like to invite all speakers to come and sit on stage as Lionel is calling you. Thank you very much.
Thank you, Paola. So please, Joanne, Hendrik, Sunita, Wilson, you can join the wonderful seats in the middle of the stage. Hello. We will have Otto Lange from the Post Infrastructure that will do a remote presentation. I myself as well will transform from moderator to speaker later on. Okay, so thank you. We are reaching the last slot in this morning session. I know it is a quite challenging spot before the lunch. It's already 12:07. Not only it will be challenging based on this time frame, but it will be as well a challenging topic. And here we're going to talk about In-Situ. And you know that I see myself, so I work in this area for over 20 years, many years regarding In-Situ, and I consider In-Situ to be the kind of terrible kid in the family. You know, the kid that's run everywhere, and when you look for him, he's not here anymore. And when you look at the past 2 days of the GEO Symposium, basically we have heard about In-Situ very lightly. Basically, In-Situ was there to make the other product shine. So the data that come from satellite or model in between were fueled by In-Situ, but there was no full credit on In-Situ. So here we are here to make In-Situ data shine and to communicate, as it was the motto of the previous symposium, to communicate about In-Situ. That is say, I would like maybe to do a short introduction regarding some highlight. So I will get close to the screen because I'm getting old, and even with my glasses, I think I have put this things into small character. So we are not coming, let's say, from nowhere. We have a wonderful session last year at the ODOC 2023 in Geneva, where we have had several presentations that are split in several parts. So first part about requirement of In-Situ data, highlighting essential variable, and the second part making how the progress is made regarding what was presented by Bente, the data sharing principle, data management principle, and how those In-Situ align with FAIR. Technical solution to bridge data gaps has been highlighted. Discussion on the organization of the community in different regions was as well mentioned, as well as international collaboration, including partnership with UN agency. And based on this, several challenges has arisen regarding how qualitative and quantitative amount of In-Situ data should be made accessible. Coverage has been addressed as well. We heard a lot about fragmentation and heterogeneity in the In-Situ landscape. We are here to tackle this. Make data and In-Situ data accessible, usable. Of course, recognize open data and knowledge. Communication was there as well. So it was not as well something that we have not taken into account. And the value of In-Situ data. And based on this highlight, we have had a year of discussion in the GeoData Working Group, and especially in the In-Situ subgroup, where all the topics that are listed here have been extensively discussed based on this initial challenge from the previous ODOC, where we talk about standard, interoperability, governance, strategy, requirement, hosting, FAIR, GEO, trusted repository, quality control, and essential variable. So you see that for In-Situ, we are not left alone. We have a very, very wide and very large framework to basically try to address how we can better share In-Situ measurement. And of course, we will not go in all of basically all those items for In-Situ, but we can pick some of them. And I think it is the value of this panelist presentation that will illustrate how basically they can tackle some, maybe many of those items in their presentation. So basically, if we look now what is basically at stake during this presentation and what has been fueled on the previous discussion. The two first points were already part of these 23 challenges, but making data, in-situ data, open, available, accessible, and actionable is a key activity. Again, fragmentation and heterogeneity should be discussed. Storage, sharing data, standard and best practices, and as well a new topic that arose as well, which is the how we address ethical consideration, including privacy and data ownership. So based on this, we're going to have a very interesting list of presentation that will tackle several community ranging from GeoGlam, GeoBond. We will have as well interesting presentation about citizen science for disaster management. We will have as well some tools that will help basically In-Situ to shine. So we will have the Direct from Joan Mazo and the Live In-Situ for myself. But we are going to kickstart with Joan that will basically guide us into the Geo In-Situ data strategy. So Joan, the floor is yours. So either you want this or this.
I don't know.
Keep it here.
We will see. So what I have to do with this? Green one, okay. Okay. So what I'm seeing here and what is shown there is different. Okay, interesting. I mean, it has been a very interesting 2-3 days, and actually, I believe my presentation is already outdated because I have been learning things, and I have shared. We have shared this view, no, that people tend to talk about space-based data with passion. This is fashionable, isn't it? It's the challenge of launching a piece of metal into a space. Sounds really more interesting than just having a bunch of sensors out there on the ground. And we have been doing this for ages. So what's new on that, no? So that's the thing that we have seen, I believe. We focus on space-based. That's not bad, of course, but there is this other aspect that we need to consider. So that is the first message that I would like to transmit. So we all know that we have this dichotomy between a space and the other things, and we call the other things in situ, even if sometimes we are talking about drones or other stuff. No, I will go fast. I'm here to present the strategy. The strategy is work in progress. This is not finalized. We want to have a stable proposal for the plenary in Rome in May, something like that. So we can see, pick and choose the role that Geo wants to be. Could be the coordinator, could be the promoter, could be the trainer, could be the communicator, the data manager, the host of some infrastructure, the facilitator, the producer, the custodian, the priority setting, the user of in-situ data, what we want to be. We need to clarify our minds. Of course, we know the challenges, and they have been enumerated by the moderator Lionel before, no? The heterogeneity, maybe not very well coordinated, because, you know, to throw some sensors here and there, you don't require much coordination. To launch a satellite in space, you already need coordination, no? So you are well prepared. In here, well, it really depends. If you are doing marine science, maybe you really need to coordinate, but not always, no? Anyway, sparse spatial and temporal distribution, lack of common standards, vocabularies, and access protocols. Vocabularies are really important because one thing that we need to do is to link the in-situ with the space. If we know we use the same vocabulary, if we know we are talking about the same, coordination is easier. The metadata, again, once again, no? The data is available, but sometimes is unknown or is not in adequate format, limited availability in some regions, some infrastructures are not well exploited, and sometimes issues with timeliness. So the dream, this is my dream. So an Earth observation in situ networks that are sustained and coordinated and providing long time series of data in line with the data management principles, sharing principles, supporting informed decisions, and addressing all key aspects of global environmental and policy challenges. Isn't that a good dream for a strategy? How we are going to do that? This is the thing. I believe, and this is where I got outdated here, I believe we have a mission. And the mission is to create a change in mentality in GEO, in the members and their activities. Is actually to consider in situ data management in all the activities we do. So to plan, to require, to find, to organize, to use, and to publicize the use of in situ data. And this is what I have learned, and I believe that should be a sentence that mobilizes us to start the strategy. Then we need objectives, and the objectives has been discussed a lot, and we want to collaborate, of course, and coordinate the different and the diverse in situ networks. We want to promote the sustainability of those networks. We are promoting a concept of integrated observing system, as well as the implementation of our principles, beloved principles, into the in situ data as well. We want to identify existing gaps, existing barriers in accessing information systems, and of course, overcome them. We want to support the existing regional networks and conduct outreach activities showing how nice is in situ data also. And we need to transcribe these things into some actions. And there are many actions in our strategy. Maybe the strategy doesn't need to do that, but I'm a practical person, so I really needed to do this exercise in this slide. So this is what I did. So those sentences are similar to the last ones, but are more pragmatics, no? Like guidelines, needs, usefulness, or the organization of essential variables, the update of the data sharing and data management principles, considering in situ data, maybe also considering the APIs for in situ, as Stephen Ramach has mentioned before. We have this central thing API standard that could be the API for in situ, maybe. Sorry, I'm getting technical here. You can guess my bias. Collect in situ data requirements that are not covered by the current data and observations, and then do something. Involve existing regional and national networks, allow best practices, exposing knowledge in the knowledge hub, I suppose, and promote success stories on in situ, including the new technologies like the Internet of Things, the citizen science, and the drone that will make our activity a little bit more fashionable. Yeah, so next steps should be to actually, apart from finalizing the lists that I have provided to you and agree on them, then prioritize and generate a schedule of activities, so look for endorsement and publishing the strategy, communicated, disseminated, leveraging the organizational capacity of the in situ subgroup in the data working group, as well as in the GIDTT. Did I say that correctly? Look for the support of the rest of the GEO work program as was requested by Angelica, I believe, the day before yesterday, and measure the progress towards those objectives. Thank you.
Oh, thank you, Joan. Thank you for this inspiring strategy outline. So I noticed that we have a framework that I presently proposed about the discussion. Now we have a set of roles. And what I like in the idea of role is that behind the role, there's human. And when there's human, basically there's stewardship in order to drive those in situ to be, again, well exposed, well shared and well known, not only for our own purpose, but for the community. And this is, I think, very good news. I like the idea of changing the geo mindset globally as well, to basically transition towards this in-situ to be, let's say, more accessible and actionable again. And the idea of transitioning from objective to activity. I think it's a very good list of action and concrete action. I know you're a concrete guy. I am as well, so I'm fully aligned with this. So thanks a lot, Joanne. Now we are going to transition with a presentation from Henrik Bogart from GeoGlam regarding the harmonized in-situ data in support of monitoring and exploitation crop production. So Henrik, the floor is yours.
This one. Well, thanks for the invitation and good afternoon. I would like to present on harmonized in-situ agronomy data. So mind the word agronomy. So we're in the flagship of GeoGlam and talking about in-situ data like crop characteristics that you can measure in the field by field visits of high resolution imagery, octocopters, that kind of, but mainly field visit in person, measuring things of the crop like phenology, biomass, yields, etc. And I would like to talk about the harmonization of such in-situ data. See, that one. Yeah. Skip this one. So why do we need in-situ agronomy data? So a few different reasons in our field to calibrate and validate algorithms that we use to produce key inputs for exploratory studies, services in support of monitoring crop productivity, in support of agricultural policies or policies of climate change, mitigation, adaptation, in the end, the Sustainable Development Goals. So calibrate and validate those algorithms and models. And we can think about these GeoGlam essential agricultural variables like a land cover crop type map, phenology, crop calendars, the yield levels, biomass, that kind of input that we need for these studies. Other reasons are that we have certain policy measures that we want to monitor, like in the Netherlands, we have catch crops that we would like to see if farmers are really doing catch crops to avoid the leaching of nitrogen to ground and surface water, or to measure the nitrogen content in groundwater. So we need measurements of that. Or for instance, to evaluate crop management practices. We do a field experiment, we do different rotations, different applications of fertilizer, and then look how the crop is reacting. And that is also an in-situ data, a reason to do this kind of work. Some examples, we need in-situ data, for instance, in World Cereal, where we train crop classification algorithms to produce maps at 10-meter resolution worldwide. So we collect data there. You see in the map where we have data and we still need to find more data, specifically more in the east. Another example is work that we are doing for the Joint Research Center, so-called MARS system, the crop yield forecasting system, where we have improved the monitoring of the crop potato by training an algorithm that detects planting dates. So you see on the left the result of that planting date that is being used as an input for a crop model. And in the middle you see two maps, and the one on in the middle is the harvest index as it was. And the one on the right is after we have applied this planting date algorithm that we trained with phenology data that we found through all kinds of sources. So that really improved. And you see that the effect of more phenology data, in-situ data, helps to make a better prediction by the model of harvest index. Another example is the Global Yield Gap Atlas, where we assess the yield gap, so the gap between actual yield of a farmer and the potential yield. Well, the potential yield, obviously, you cannot detect by remote sensing so easily, I would say. So you really need crop growth models to simulate potential yield levels. And to make that locally relevant, we use field experimental data to train the crop growth model to really estimate yield levels in the right way, potential yield levels. So here you see an example of China where we simulated, calculated yield gaps for a certain crop that I cannot really see it from distance. This is also working, yeah. So this is wheat, indeed. So this is an example of wheat where we estimated yield gaps for wheat. And a final example, we also did cocoa soils. This is a big study, long-term study with industry, but also universities, where we try to improve the crop management of cocoa plantations to make it more sustainable. So we measure different characteristics of the plant with many different locations, and we also manage the data in a certain way in the geo network to also publish data, but also sensitive data that cannot be shared is being dealt with in a specific portal for the, yes, thanks. These are examples, but we need this in-situ data, but it's difficult, and that was, you already mentioned that, Lionel. So finding this data is difficult because there are many sources, difficult to find, limited access. For instance, the data policies are not clear, the formats are not clear, there's inadequate data standardization, unknown data quality, and also inconsistent, incomplete metadata. So it's really nice that this data is shared, but it's not really fair, I would say. So there we come with there's an additional task. So there is a kind of need for a community-specific solution to find, collect, and harmonize this in-situ data that is already published. And here's an example on the right. So we have 3 different sources, and one is in, I think it is in Zenodo, the other one is in Harvest Dataverse, and the next one is in Figshare. I'm looking for observed phenology for potato. Think about that, that issue that I wanted to train algorithms to detect planting date. So what I need to do, I need to find the data, I need to download the data, I need to understand the data, so I need to check background documents, I need to extract the data, harmonize the data, save it somewhere, and then I can combine it and use it for my work. So it would be very nice if that is already done, and that is what I call harmonization hubs. So really harmonizing the in-situ data that's already published and make it really useful for reuse. So there are 2 initiatives, World Serial that I already presented, but also AgroStack on the yield modeling. And those 2 initiatives find the data, curate the data, and make it available for specific applications. This is also published in the GEOS portal. We're now working in this GEOS Platform Plus project. We have a use case there where we publish the World Serial data, but also the AgroStack data. And that is also a way to ensure the sustainability of this data set, because that's a problem. Initiatives like World Serial, they will end. And what will happen with the harmonized data that we manage there to train algorithms? That still should be there, should be sustained. So this is a way of at least making it available for the public. And we also would like to publish that in the Geo Knowledge Hub. So the key messages, last slide, is we really stimulate sharing of in-situ agronomy data, of course, by data management plans, data guidelines, training tools to make it really easy to publish, or at least the metadata so that we are aware of certain data sets. But I think it's also very important that we do some additional step, I call it these harmonization hubs, that we make it really reusable for certain applications like crop type mapping or calibration of a crop yield model. And that requires some more investment in these hubs beyond projects. So cost for maintenance, curation, but in the long run, we will profit because we are more efficient. We don't need to check all these sources ourselves and try to understand these sources. It's already there. And then it leads also to higher quality because you have access to many different sources right away. So that was what I wanted to share with you.
Thanks a lot, Hendrik. So it was, yeah, very interesting to hear from you how these in-situ data glue together all those research application products. So here we face the importance of this in-situ data. I like the diagnosis as well that you set up, which is not an easy to solve when you list all these, let's say, potential issue to go to FAIR, but you have tackled most of them. I have two suggestions. Maybe you mentioned GeoKnowledge Hub, but regarding the spread of data into various repositories, I guess that I know the GeoKnowledge Hub has some capacity to potentially glue those remote sources into a knowledge package thanks to the harvesting mechanism existing in the GeoKnowledge Hub. So I think it could be a good exercise to conduct as well. And if I may, I see that most of the format you mentioned were Excel and CSV. I think maybe there's more actionable format that can be think of. Okay, thanks a lot for your presentation.
I will reply later.
Yeah, thanks a lot. So next we're gonna invite Sunita Shodai from GeoBond, AOBond from biodiversity example. The floor is yours, Sunita. Either one of the other slides.
Hello, everyone. I can't see, so I'll just go here and then read from the screen here. So I'll be talking about some of the in-situ data that we have been collecting at ICIMOD, though I'm affiliated with APBond, but we are also working in the Hindu Kush Himalaya at International Center for Integrated Mountain Development. So in terms of physical geography, so I'll take you to the Hindu Kush Himalaya region, which we think is one of the most important global resources sitting at the peak of the world. And if you see, this is the region that is really stretches as the 3,500 kilometer along from East Himalayan to Western Himalaya, covering an area of around 4 million square kilometer, and it has around 54,000 glaciers we have mapped through satellite images, but also it has around 60,000 square kilometer ice and 6,000 cubic meter of ice reserves, which really provide evidence that this is the third pole beside the North and South Pole in this globe. So this region is extremely rich. I also talked before that this is extremely rich region in terms of biodiversity, but also cultural diversity, and also in terms of water resources. But this is also the region which has a lot of challenges and so many challenges such as the climate change, demographic change, pollution, and also other changes, especially the natural disaster. You might have seen in India, Nepal, Bhutan, or even Bangladesh, we have flooding now and then every year. And the intensity and the number frequency is getting higher and higher since the last few decades. So that's why in terms of the challenges in the region, but also the need for the region, we have been collecting a lot of data. Beside the satellite imagery, we also have in-ground in-situ data collection system, long-term monitoring system. So there are so many, but I'll just briefly touch upon how we are doing the snow, permafrost, air, monitoring system, biodiversity and ecosystem, especially focusing on forest, rangeland, and also wetland, especially high altitude wetlands, but also a lot of globs. We have mapped out a lot of globs, but also disasters, which are cascading disasters from Himalayas down to the Bay of Bengal. So here, permafrost is a very new area. We have started to map out the permafrost, and we have some station across the region where we are trying to collect the data on permafrost, which is really, it's a challenge because you know, in the Himalayas, there is very high accessibility towards the region. It takes like at least 5 or 6 days just to reach to one site station. So it's really difficult for us to map out all the permafrost, but we have started because permafrost we think is an important area of research because it's once we know the status and distribution of research, it's really important for us to know in terms of trying to have the policy actions in terms of hazard or also the different kind of hazards, especially the avalanche in the snow. So we also have Springs Resource Mapping Initiative across the region, but our initiatives are really very active in terms of India, Pakistan, Bhutan, and also Nepal. And here we have adopted two approaches. We collaborate with the government to map out the springs resource. If you know, or if you do not know what the springs are the natural outlet that really comes out. It's a pathway from the ground outward water to go to the surface. And this is important because this more than million population in this region really depend on springs for agriculture and also directly drinking water. So that's why for this one, because local people are quite important for this one, so we collaborate with the government as well as we have adopted citizen science to map out all these springs resources across the region. And also we have protected area systems and also database in the region. We collaborate especially with the governments to really map out the protected areas, especially the area. And now we have also started to map out the other effective area-based conservation measures that really contributes to target 3 of global Kunming-Montreal Global Biodiversity Framework. So you might be reading in the news that sometimes Delhi, sometimes Kathmandu competes with each other to be on the one of the polluted city in the world, especially during the monsoon, especially during the winter season from October until February. So that's why now we have air monitoring system across. We are trying to do this across the region, but our monitoring stations currently are in Nepal and also in Bhutan and other regions, and we are directly collecting the data and providing to the governments and other end users so that we can act on time. So if you see, so what? So we collect a lot of data sets. So what do we do with those data sets? So we have a regional program especially supported by NASA, and we call it Surveyor HKS. So this is one of the infrastructure we have in place to collect all the data set, and we deposit here for analysis and also to support our governments and also to support our other stakeholders. We really want to improve the awareness, but also improve the access to the geospatial data that we also collect from across the region, because we want to increase the provision of high quality user-tailored data, and also we provide tools and different kind of application and models to really support the decision making at the regional, national, but also especially at the local scale. So beside those in-situ data, we also focus on a lot of other demand thematic focus like agriculture, like Professor presented earlier. We also have a lot of climatic services, especially focusing on hydrology and water resources, but also land cover and land use, because this is demand-based from the government, and also a lot of air quality as mentioned. So this is also because it's not only about our thematic focus, but also the demand from the governments and the local people. And if you see why Delhi and Nepal, Kathmandu has been on the top list since a few decades, because of this fire. So we have so much wildfire and also human-induced fires in agriculture, but also the forest fires. If you go to Nepal, you can see the thick blanket of air pollution in Kathmandu from December until January, because there is a lot of forest fire in this region. So that's why with the demand from government of Nepal, now we have collaborated with them just to monitor detect the fire and also monitor the fires. And we have the early warning system through mobiles to all the government systems and also the local people, so that they can really get the information and then go to the place and then try to act on time. So we have this well application live outlook where they can see where the fires are, and they just go, we have the fire response team at the local level, and they try to get information there and then try to act as much as possible. But of course, there is a lot of need for capacity building, not only to go there, but also in terms of data analysis and also like very basic things like fire, very basic things they do not have at the local scale. So we still need a lot of effort to really work on this web application. So on request, we get a lot of requests from different stakeholders, and these are some of the demand-driven applications and case studies, which really focuses on crop mapping, but also trying to build the capacity, especially of the women. So we have like specific JC-focused capacity building GIS training for girls and women across the region. And also we get a lot of demand from the Department of Hydrology and Meteorology. We collaborate with them to get the data sets, and also we do a lot of forecasting, and also floods and flood warning system in Pakistan especially, and also in India. And also one of our important objective is to whatever we get, we try to deliver it to the government. So we get also the requests from the governments like Bhutan, and then whatever we do, we just pass on through the government for them. So these are the main repository of our data analysis and repository system. The one is the Survey HKS. The other one is what really has from since last 15 years. So it's the regional database system. So we have some protocols. So once you get into this system, so the data is free, because we believe in open data policy system. So we try our best to provide all the data to our users. So I think that's all from our side. Thank you.
Thanks a lot, Sunita. So you outline a quite very large example of data set. You mentioned In-Situ for snow, permafrost, biodiversity. I didn't have time to notice all of them. So thank you, Aldin. Citizen science as well, you mentioned. So that's a large amount of data that could be, that are basically supporting by various platforms as well. I mentioned the Servier, the web application Fire. I think you are already addressing capacity building, so that's a wealth of information. Maybe regarding this presentation, I find myself a bit, let's say, wondering where are those In-Situ hidden? Should we access them in a very, let's say, easy manner, or are they only fueling the product? This is something that I would like to maybe inquire later on, but I think it's a very valid and very inspiring information regarding biodiversity and how to address this In-Situ to support all those applications. Thanks a lot. So I will switch myself from moderator to panelist and try to walk you through the presentation of lib-In-Situ. And lib-In-Situ is a Python library that we have developed, and basically that do the transition in order to potentially try to address fair approach for In-Situ measurement, and not only putting some, let's say, nice acronym onto, let's say, a work, but trying to put all together all the steps in order to make your In-Situ data align to FAIR. So I will briefly present the context regarding In-Situ measurement. We have heard this since the past 2 days as well. The conjunction with other EO data is key for calibration, validation, fusion, but there is a need for a real actionable In-Situ measurement that will enable interoperability between data system and infrastructure. So this is exactly what we want to address this. And we have some supported framework to do so. It has been mentioned this morning. We have the Geodata sharing principle, the Geodata management principle, and as well the FAIR. And so this presentation is aligned with FAIR. I could have done it using Geo. I would have 10 GeoDMP. It's been easier to work with only 4 FAIR principles. So for those principles, findable metadata and data must be easy to find. That's the key. Accessibility, user need to know how to access metadata and data, for sure. If we do both, we will basically be interoperable, where data and metadata must interoperate with application. And of course, if we want to make data reusable, those metadata and data must be documented. So lib-In-Situ is at the core of this FAIR exercise, and it is a free and open Python library that basically will transition with an operational pipeline from raw data log into actionable and interoperable In-Situ measurement. So basically what does lib-In-Situ does, it fetches the data from network via FTP, CSV, dat file, text file, and it creates a data collection. And then you can define with the schema common data line, a data process that basically will encode your CSV or dat file into cube data with enriched metadata. In our case, we follow climate and forecast convention for naming the variable, and it creates automatically a netCDF, climate and forecast convention compatible, that you may decide to host on a thread server, which basically expose your data into various already existing operations, and as well with the support of OpenDAP, the Open Data Access Protocol, which basically will allow you to expose your data via web apps, notebook for doing QC or simulation, or select your preferred language for doing direct access via machine-to-machine type of operation. So in order to demonstrate this, and going back to the FAIR, let's say, elements, so if we want to be reusable, we must be documented. So we have created one single page called libinsitu.org, where you can find everything you need regarding this libinsitu example. So of course, you will find the source code, you will find how to set up, you will find the documentation, you will find some example regarding Jupyter Notebook using libinsitu to fetch data. We have created nice notebook to basically access and to do QC control. You will find an academic paper, you will find mailing list to communicate, a very nice web viewer, I will come back to this, and some example in the thread server. So to be accessible, basically, we need to make the user know to access metadata and data. So thanks to the thread server, we can access the metadata and the data with two basic operations, download and subsetting. It's already very good. And we have as well the support of OpenDAP. And basically, OpenDAP allows you to request the data remotely. We have currently set up for the renewable energy a list of over 600 stations, over 13 networks from over 20 years. At minute time spent, they are encoded in netCDF format following climate and forecast convention. And by the way, netCDF is a very compact format. All the archive is 10 times more compact than the raw CSV archive. And then what we have tried to exemplify, if we want to be interoperable, so those servers and those data need to communicate with other applications. So we have developed an open source web client, so you can see it, but you can download it for free if you want. It is open source. And basically, we have done here, what you see is requested on the fly. So all the stations are currently being remotely requested by the client onto the thread server, and you have this presentation, you have a list of all the variables available. And if you look into a variable, you have a nice representation of the time series. But not only, you have as well the extraction of the metadata that are in the netCDF file. So you have a very nice list following climate and forecast convention of metadata that are embedded in the netCDF. And as well, if you want to extract the data, we have possibility to extract the data and to basically select time range, select the resolution. So subsetting the variable, it's a very easy. And as well, if you want to download in CSV, you see that we are considering the people who want still working in CSV. You can do so, but as well, you can include the header of the metadata. I think it's a very handy feature. So we see some example regarding interoperability with Python Notebook. We have done some quality check for all the stations. So it's a very nice way as well to implement this access to remote server. And last but not least, if we want to claim to be findable, we have created some metadata. We have a catalog, a geo catalog, and we have created metadata following ISO 19139 profile. And these metadata are accessible on the catalog. But not only, they are harvested by the Geo Discovery and Access Broker, so they are available on the Geo portal. We are findable on the Geo portal. And of course, we have created a package in the Geo Knowledge Hub, and we are available as well and findable into the Geo Knowledge Hub. So to conclude this speech, libinsitu, you can use it. It's open, it's free, it's documented, it's illustrated, and you can download it for free on libinsitu.org. We have basically demonstrated that it is a quite consistent and efficient pipeline for FAIR and Geo throughout the various elements that we have set up, thanks to the release of libinsitu. It is currently operational, supporting some CAMS radiation product in the Copernicus Atmosphere Monitoring Service program. We have discussed with many networks who are interested in the basically spirit and have potentially transition regarding moving from CSV up to netCDF following this approach. We have discussion with the OGC in order to potentially think of how we can have a certification process for libinsitu. This is still ongoing discussion. We have a SME that basically use and access our thread server for doing on, let's say, solar forecasting application. and they are finding very easy to have those access to the lib-in-situ and to the threaded server. Sorry. It is reproducible. We have already the marine radioactivity sorry, service that have used it. We have a working document which explains all the recipe. You see the download, and we have a dialogue mailing list. If you are interested to basically share, communicate with us, bring us some feedback on some issue on the lib-in-situ, we are happy to discuss. And with this, I thank you for your attention. So thanks a lot, Lionel, for this very nice presentation. And now I'm going to transition to another practical aspect of the in-situ landscape. I will turn to Johan, who will present us the GREX.
Yep, thank you. I believe we are all tired, so I will break the protocol and the escape. This is a work that I have been doing with Alba, there in CREAF. That's a research center next to the Autonomous University of Barcelona. This is to amend the first light. Where is the, yeah. So, blah, 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 blah. 3 messages to take home. 1, we need to start to collect requirements for in-situ. This is the first step to organize ourselves. Second message, we are providing a tool to do that. It's called G-Rex, and it sounds like T-Rex, so it has a dinosaur. Number 3, if you have needs for in-situ data, please go to a URL that I will provide just next and help Geo to actually collect in-situ data requirements. That's all. Do you have in-situ data requirements for agriculture, maybe? Just visit our thing. I know that the mountains people, they have special requirements. Go here and document that. Your presentation hasn't been done, but I'm pretty sure you have requirements. So that's the, where is my clicker anymore? I have lost my clicker. Okay. So it's quite simple. We are trying to do it standard. You know that I'm working in the OGC, so a standard is all my life. So based on that, this is mainly requirements, but mainly metadata. So the problem we have is systems like that have a clear goal. For instance, the weather people, the WMO, they have one. So they know exactly which kind of products they are looking for. Here in Geo, we are so diverse that we needed to abstract that. So we created this concept of need that is actually what you can do with in-situ, no? Maybe you can Calval, everybody does Calval here, but you also can do other things, numerical modeling, demonstrating scientific hypotheses, harmonized essential variable products, deploy sharing data system maybe, or calculate an indicator for monitoring policy, or assist decision-making in general, who knows? To do that, you do some tasks. Too complicated. We didn't implement the tasks. The tasks require data, and those data has requirements. So this is the part we implemented. So we want to know which is the topic that you are interested in. We want to know which the area you are interested in. Data quality limitations, time ranges. Do you have barriers? Which barriers you can overcome, which not? And do you have special things like need to coordinate with other kind of measurements or even distributions of in-situ data, whatever. Probably you have a product in mind in the end. So if you want to report with that, fine. Well, we have a form. We are not very original, actually. We have a form to actually capture that. This is how it looks like. If you go to this www.grex.grumex.cat, you can do it yourself. Please help us as soon as you can. This is, of course, fair things. So we needed to make the database accessible. So of course it's accessible. Everything that we are capturing, of course we offer to anyone else. Clicker here. And well, we start having some data and we are producing some graphics and some analytics. And the intention, of course, is to actually know which are the most common needs. And which are the most common need essential variables, which is the geographical coverage that is more common, which is the type of data access that people prefer. So, of course, we are trying to know that the more data we have, the more precise we will be in this diagnostic. So, for FAIR, the R is for reuse. So, after we collect all these things, this is the green part in the top of the slide, we want to connect, because this is kind of a marketplace if you want. We have users that have requirements, and we have providers that they have the data, or maybe not. We need to do this matchmaking. And when this matchmaking doesn't work, we need to find out why. Maybe there are barriers for the access, maybe the data doesn't exist at all, and we need a new product. So that's the way forward that we see in this tool. We are not there yet. So that's it, easy. And I have more of those, eh?
Joan Mazo time show.
Thanks a lot, Joan. So I know the G-Rex, I like the G-Rex, and I see some linkages that we may think about regarding GeoDMP, G-Rex, and In-Situ. Altogether, a kind of, let's say, workflow for making these things, let's say, not silo, and definitely smoothing the In-Situ global approach.
And we have to go into the GA-DTT and discuss those aspects.
Absolutely welcome. So last but not least, I'm really thrilled to hear now about Wilson Muyaradzi. I hope I didn't scorch your name, about citizen
right.
science for disaster with management and vulnerability mapping. So the floor is yours. Either you want to have, yeah, you have already mine.
Thank you very much. I hope I'm audible. Is it? I think I need an interpreter because my presentation is going to be in Shona. Did you organize an interpreter for me? You didn't. Okay, let me switch to English mode. I work like a machine anyway. So, ladies and gentlemen, my name is Wilson Mnyaradza. I work for Humanitarian OpenStreetMap team as the Disaster Service Manager for Eastern and Southern Africa. I would like to share with you some of the work that we have done in Eastern and Southern Africa region around mapping for disaster preparedness. Okay. The first question I would like to pose to the audience is, what if the place you were looking for could not be found on any map? Not because it's hidden, but because it was never mapped. And what if people in need were living in unmapped places? How can we locate and reach out to them, especially in the face of a disaster? If we have answers to this, I think we possibly can save lives and livelihoods of those people in communities that are vulnerable. Who we are. Humanitarian OpenStreetMap team was actually founded out of frustration. It is a non-profit organization based in the US. It was founded after the Haiti earthquake. Most responders wanted data to respond to that disaster, to the earthquake, but they could not find the data. So what next? They decided to come up with an OpenStreetMap platform where we contribute and map and create data sets that can help in terms of humanitarian assistance. We are comprised of so many skilled and committed staff members, particularly volunteers. I've seen 3 of them in here who are also volunteers of the OpenStreetMap platform, and they've been invited here, and I'm so happy to see them because oftentimes they make my life easier and my work easier. We believe in free geodata that can help save and improve lives in terms of political crisis and natural disasters. I think everyone in this room is more centered on data sharing because most of the organizations that I've come across, people often operate in silos and data and information is often not available. One of the speakers who was in that corner actually asked a question which is very valid to say, how do people have the knowledge to access the data and also interpret and use it themselves? It is very critical in terms of decision making and also making the communities themselves empowered to be able to see which areas they are affected and how best they can put best practices to avoid loss of lives and also livelihoods. So the OpenStreetMap platform is more like a collaborative project to create free editable map data and also source of geospatial data, like I said earlier on. And everyone else can actually log onto the site. You can also actually register, log onto the site and be able to upload or even download data that you need for any specific contest, right? We also work with partners. I had several presenters in here. They were mentioning the issue of partnership. You know why? We cannot do all these things alone. You need somebody else to aid you in terms of the resources to be able to do it. Every other person in this world is focusing on trying to see who does what. If you're into drone mapping, let's have a partnership. Let's work together. How can we best integrate your technology into the work that we are doing? So what we do ourselves is we support humanitarian response by creating open map tools and open source tools also to respond to disasters, especially in vulnerable communities. We mobilize contributors to generate data for development and humanitarian response. That's why I mentioned about the communities, OSM community, the youth mappers that are globally located. We also support open mapping communities to prepare for and respond to disasters. Like I said earlier on, our focus is community-based to ensure that these communities that are living in vulnerable contexts have access to information, data, for early warning systems, and also organizations that are also into disaster risk reduction have information and data to be able to support their decisions and save in terms of resource allocation. We also build capacity, provide technical and non-technical support to our audience, particularly even the contributors themselves and even map users. We mobilize funds. Of course, you can't do anything without resources, right? So our focus is more centered on mobilizing funds to address local challenges through mapping. And the tech part, we also have a tech team from the HOD that develop free, user-friendly, open source mapping tools. Our focus is mainly on promoting open source data and open source tools for mapping. Partnerships, back to the issue of partnerships I explained earlier on. We create maps with organizations worldwide that support local decisions. We also focus on the quality of the data. I think this is one aspect that most of the people in this room will always ask and say, oh, okay, you have got the data. How granular is the data, okay? I'll switch gears now. Community-centric approach. You realize that our strength is mainly focused on investing in empowering emerging leaders with the professional skills to advocate for the creation of open mapping data. We manage and mobilize volunteers and work with several organizations. A good example is like the FAO campaign. For some of you, I think you have had access to this campaign that we did with FAO, where they reached out to us to map in preparation for El Nino. And we were covering 3 countries in East Africa. That was Ethiopia, Somalia, and Kenya. I mean, the good news is we managed to create the data sets that they needed in a space of 2 months. So there is power in terms of our strength in terms of mobilizing mappers to create data sets timely for any response. We also have expertise in open source tools. I also mentioned that earlier, and enabling data use, which is very critical. A point that was raised by one of the audience, one of the colleagues of ours who was standing up there. I can't remember the name. So we work with our partners to ensure that the systems are in place to use the data gathered effectively. Here we go. Which tools do we use? I think people, you heard me talk about OpenStreetMap platform. This is where the repository of the data, which is free to access. We used for data collection ODK. Most of you mappers are familiar with it. We also use OSM and Mapillary for street level mapping. We also use the field mapping task manager. It's one of the tools that we use as well for data gathering in the field. We use QGIS, particularly for importation, analysis, and visualization, which is very important. We also develop interactive maps using open mapping tools such as Tableau. And also, we also used the other one, but now it's now a subscription-based platform, which is Felt. I think some of you know about it. Now, back to citizen-generated data for strengthening anticipatory action. You realize that in Africa, particularly in most countries, we are impacted by weather extremes, right? And these affect close to about 110 million people. within Africa. So we try as much as we can to build data sets to support such initiatives around creating the data that can help in terms of decision-making, planning for disasters. So we have realized that most stakeholders lack comprehensive, accurate, and up-to-date map data, right? So to affect their planning. So we always engage to understand where is the weakness? Is it the tools? Is it the data? If it is the data, how can we provide the data? We also provide the training. You realize I'll give you a case study in the later slides. And oftentimes, it's not only citizen-generated map data freely available, but open source mapping can help bridge the gaps and enable timely early warning for communities to adapt to or mitigate the effects of climate crisis. All of us, you are aware that we are facing various climate challenges, and some in certain contexts, you are realizing that you are experiencing some weather patterns you're not used to. This in itself needs some interventions. 1 minute, oh my God. So we had a pilot in Zarabani. The idea was moving from a reactive to a proactive approach when dealing with disasters. So we wanted to start small, assist to develop and test proof of the concept in an area where we have got good connections. And then we engaged with stakeholders to understand the gaps, like I said earlier on, and then understand the gaps also in tools. And then we also co-created projects with these partners, and we worked with Caritas Zimbabwe for this pilot. So we had a data model, which was mainly community-led. Like I said earlier on, we always encourage community-led initiatives. So the communities and the stakeholders guided the development of the data model because we wanted to go granular. They were the ones who identified the features that needed to be mapped in this context, and also the attributes that needed to be captured so that they can help us in terms of analyzing and giving them like information and data that is based on geoscience. So here we go. We managed to produce both static and interactive maps. And we also had general reference maps to provide a general overview and understanding of the existence and distribution of relevant points of interest. And also thematic maps that showcase information on communities exposed to disasters. On that map, you realize that those were health facilities. That was an analysis where we wanted to understand which communities are furthest away from these facilities, like health facilities, where they can get some health assistance, say in the case of a disaster. This we wanted to prove to the government and also the Ministry of Public Works that if the clinic is furthest away, why can't you mobilize and influence policy to construct even satellite clinics close to those communities furthest away from that resource? Impacts and outputs. So it was more incorporation of participatory mapping, like I said earlier on. So stakeholders themselves provided feedback to these map products to ensure that there is accuracy and relevance of the data, you know? So we are going back to the community to give us that feedback. Data-driven decisions. They also managed to come up with multi-hazard contingency plans to enhance disaster planning for the district, right? And then they also were able to to identify evacuation centers based on the attributes that we did run, more like an ARA analysis. I heard someone talking about language here. Python, Java, and stuff. We used ARA analysis to at least identify these evacuation centers. So Caritas Zimbabwe also managed to make decisions where they had to rehabilitate one of the schools to accommodate people with disabilities in the case of disaster. Yeah, we did a case study, like I mentioned earlier on, with FAO for the El Nino. As we speak right now, FAO Swalim also approached us to also work together with them to create data sets in preparation for La Nina. So we are mapping surface water sources in Somalia, the whole of Somalia. We have finished the northern part, and our guys have also mapped the southern part. We are busy validating that data so that it can be fed into the early warning system so that they can prepare. How we can work together, we can help you get access to data that you need, and also support you to use geospatial data tools, maps in your work. So I'm not going to explain further because of the time limit. We also can support your organization with information management into your GIS capacity, also to link you with our OSM communities in terms of generating data within a short space of time to help you understand and manage and integrate OpenStreet data and tools into your work. Yeah, I think the most important here is that you realize that open mapping data can help identify vulnerable populations in areas and infrastructure as well. So all this work is mainly centers on providing solutions to the challenges that the communities are facing. We try to fill gaps for decisions in disaster preparedness by using community-led mapping to collect critical missing data. The community should be the one to inform what needs to be mapped. You realize it's the other way. It's not us who approach the community and say, yeah, we've got these tools. We need to map this because it doesn't exist. We go out, we find out from the communities, what is it that is missing that we feel is critical. They feed into the whole system of the development of the data model, which we use to collect the attributes to become more granular in terms of the data that we create. Because if the data is not granular, the challenge is like, it's not easy for people to carry out an analysis, you get. Here we go, done. Thank you.
Thanks a lot, Wilson, for this very inspiring talk about citizen science. I really dig into what you mentioned regarding how you scale practitioner skills, basically how you do, saying you do not things together, which I think is key as well. Being community-centric, we heard a lot about user-centric, but now we have this community-centric. I like as well the idea, and maybe community does not ring the same, maybe in Africa than elsewhere. So I think this maybe social aspect could be considered as well. And if you look at what has been presented, so regarding data in this session, regarding in situ, citizen science, but as well in the previous session regarding space data, I think we can basically think that GEO is the proper vehicle and the proper forum to be there all together, to glue all those things together in order to make basically and convey the message that open data, open science, open tools, and more generally, open knowledge, as has been presented this morning, is the key of the GEO basically motto. And I think we should be proud of this. So before, maybe I have some prepared questions. We will have a final message from Paola, but we have still time before lunch to take questions from the floor. So I see already hand raised. Karel, France.
Okay, thanks for a very interesting presentation. I have two questions or comments, yes. First, how to deal with the fact that the most of in-situ data are in the hand of private subject or cities, and how to integrate this, because for example for GeoGlam I think that most of real in-situ data is in the machinery, is in the farm, but also in the producer of climatic sensors. So this is one thing. Second thing, which is in some way the direction a little against this sharing data, is the effort to do more and more computing on the edge, yes, to analyze directly data on the edge, and to give feedback directly from the sensors. Of course, it is related to many things, to machinery, to other, and of course, is this also linked with artificial intelligence? How this second direction can influence the sharing of the data?
Maybe I see Joanne, you want to take one of the two questions from Karen?
For the first aspect, the private data, we had a presentation about licenses that I believe is very relevant in here too, even if it was in the previous session. The other thing that I would like to say is that, at least from the technological and governmental point of view, in Europe, we are now developing a thing or a collection of things that they are called data spaces. They have an extra technological piece that is called connector that deals with contracts and should enable the exchange of private data under some conditions. And I really hope that this thing can solve once and for all this dichotomy of open data and private data, having that in a single space that is able to dealing with both aspects based on trust and data sovereignty. We will see if that finally flies. We are designing that. We are starting to build those data spaces as we speak. About the analysis on the edge, it really depends on the application, I believe. If you really want to do alerting, you don't care about the normal numbers. What you only want is to detect anomalies or fires, or that's the perfect solution. Because then you reduce the traffic, you just inform what is really needed. That's a good thing. I believe you already said the question, what is going to happen with data sharing and other kind of applications that the same data could have? There is a danger there, I believe.
Thank you, Joanne. Is there anyone in the panelists who want to react or to answer to this? Or should we move to Hans' question?
Yes, I have a question and a comment. So thanks for these presentations that point towards many issues that we face or you face with in situ data and also some solutions. But since I worked, before I joined the Commission, I worked at the German Weather Service, I feel a bit inclined to defend the reputation of in situ data. There are operational networks around maintained by the weather services and many other organizations that run very precisely, very accurate, well-calibrated in situ networks. There are the environmental agencies that measure air quality. So we do have a wealth of very well and SI traceable measurements. If we wouldn't have this, we would basically know nothing about the state of this planet. Because satellites are nice to complement these in situ data to give a global picture, but without really precise measurements, we would know not very much. So just to say this, it seemed to me that you kind of take all of this wealth of data as a given, and what you look at, you don't look at the operational data sets. We have Argo floats, we have ICOS, we have, just to name a few. Yeah, there's really a lot. So basically, the problems you see is with the research data, right? So probably would be useful to make this clear that you look only at a specific part of all this picture. But back to the also of the operational data. I mean, there are also organizations around that that also deal with these issues. There's GCOS, there's GOS, there's a number of other organizations. My question is, where do you see GEO? What would the role of GEO be in this context? Also keeping in mind that probably the main issue with in situ data is, again, we come back to the topic of funding. In situ measurements are very expensive. It's probably also something that should be said sometime. It's much simpler and cheaper to launch a satellite to give you a global measurement than it would be to set up and to maintain a global with a certain density network that does proper measurements or observations. So the question is also to what extent do we also look at a funding issue again, or how do you balance this out? But the key question is, what role do we see for GEO, given that there are a number, WMO and named them, a number of other, also in the global level organizations that with in situ measurement.
And Rick, please.
Maybe a first quick reaction from my side. What I was presenting was really on field experimental data around crops. And there you see that universities, organizations do that in many different ways and share the data in many different ways. And there, this is really complicated to get all that data in a nice shape that you can use it in your applications for crop modeling and training algorithms for crop classification. So in World Serial, it was really difficult, and we put really a lot of effort in standardizing the data, and then not as a CSV or an Excel. That was a misunderstanding. What we're doing in World Serial, but also in Agrostak, is serving it through API, REST APIs, in a standardized way, with standardized variables, ontology based. And so that was maybe a misunderstanding. But on that topic, it's really heterogeneous. But I also have the experience from the Mars project for the European Commission, where we use GTS from WMO, but also secondary networks from Spain, Italy. They're quite standardized and nice. You can nicely work with them. Although there are still issues that they suddenly change their API, and then we have a problem because suddenly it's a different unit or something. So there are also issues there, but mainly these climate networks, they work pretty fine, yes.
I just want to agree with the comment because generally for us to collect the snow data, we do expedition twice a year. And going up to the glacier, it takes like at least a month just to go there, stay there, and then monitor all the glaciers. So it's quite expensive. And then after collecting all the data sets, then after the project ends, we have no funding to continue those kind of monitoring in place. And then we keep getting a lot of requests like, we need to continue, but what about the funding? So my question also to Geo is like how we can continue such. We are inspired by whatever we are doing, but like how to sustain this kind of initiative, which is often too expensive and also highly risky for there are few people just who can go up there and survive in the glaciers for many days. It takes a lot of time to collect such data and then standardize at the regional and the global standards. So my question is also to all of you and also to the Geo community, like how do we continue this? So sharing data is another issue, but we also need to think about the sustainability aspects. So just wanted to comment on.
Okay, we have as well maybe some answer to the question or some further.
I'll do my best. So actually, thanks, Franz, because you put a very important aspect in our discussion. A lot of those standardized, organized communities are approaching Geo, and I echo very much the fact that since they have been well-funded to be established, now they are pushed to the direction to provide services in order to be sustained. So actually, we should probably be thinking how Geo, now that we enter the era of Earth intelligence, which also means user-oriented and service-oriented provision of support in our vision, etc., probably this is the way of how we can attract them and help them provide services combined with the other products that we are doing here. So actually, we are talking about fusion of data. We have the satellite data, we have the in-situ data. So probably this is the direction of the solution that we are seeking for in order to attract also those communities closer to Geo.
Okay. Marie-Françoise, you want to intervene? Yeah. Thanks.
I just wanted to bring a little bit of my meteorological experience. So a long time ago, WMO has defined the data they wanted to collect for in-situ. More recently, they have defined which are the long series, which are critical. So the stations that are critical to keep on to make long series over several hundreds of years. And here, I think that with GREX, the goal is to identify which are the critical in-situ measurements that are very impactful for the communities, for the users, which are the ones which are the most used to try to identify priorities on which we can focus. And if among the priorities we identify that the glaciers have to be a priority, you have mentioned a lot of networks of in-situ that are public in-situ, but if we identify some collections that are impactful for the humanity, maybe this is a place where Geo can help with some fundraising for this very specific data. I don't know, it's just to identify the role of Geo. So help identify the priorities for the needs of the Geo community. And when these priorities have a specificity because they are difficult to reach and they are critical and very impactful, then maybe see if we have to find more original and creative ways of funding.
Bente?
Yes.
Yeah. and then Ari.
Bente Liliaby. So I have been part of the Geo family community since the beginning. And following up on what you said, Evangelos, And from the beginning, we are talking about in situ data and Earth observations as they are not the same. I want to remind us that the definition of Earth observations in GEO is space-based and in situ data both. I used to be representing the European Sea Level Service, so in situ data. And in the beginning, I always raised my hand, remember the in situ, and we are still here. So I just maybe as a part of the strategy work, now Andy has left, yeah, maybe as part of the Earth intelligence work that you should actually highlight this definition that we are talking about both space-based and in situ, because I think this will be helpful for getting resources to continue the work.
Thanks, Bente. Aris, you want to add some
Thank you,
comments?
Lionel, and thanks to the panelists for the nice presentations. I'm the one that I'm always speaking about good examples, and I think that we don't have to lose one more time. Seeing now that it's still challenging to access to the satellite data, although Copernicus and there are many other initiatives and flagship programs that are providing networks today to accessing to the satellite data. Imagine how ambitious it is to get access to an integrated set of in situ data. But Hendrix, you presented a very good example of in situ data relating to agriculture, to yield production. And yesterday in the One Health parallel session, we also mentioned the need of accessing to health data. So we have very good examples to start with. We do not have to reinvent the wheel. We don't have to lose much more time in finding priorities or needs of users. We have the flagships of GEO. We have to say, what is possible to integrate there in terms of in situ data to serve these flagships. And I think One Health or agriculture, are very good examples. So let's try to see and let's join forces, the members of GEO, to see, what is out there. In my institution, we're also collecting data from, we're paying consultants to go outside to the field to get phenology stage data or yield data. We own data. We would like to share the data. We are uploading data to Mapillary. So let's start with one or two good examples in agriculture, and One Health is some two very good examples to start with and share data to see how good we are in developing some data sets and benchmark data sets to build up on research. Thank you.
Thanks a lot, Aris. So we are reaching the end of this session. So I know I see some hands, but I think we need to wrap up. Maybe one last question, you gentlemen?
Yeah, thank you. I just want to comment from that in situ data is expensive. That's actually not true. Maybe in some cases, now, especially with the penetration of mobile phone, everyone is sensor, and we all are sensing. Just the way how we can harvest this data set. So if we can make that mindset, that if we can use human and mobile phone, then I think there will be no problem of in situ data. And we have example, even in Nepal, I am collecting in very remote area with the smartphone data. It is capable to do very high quality mapping. So it is possible.
Yeah, for sure, for sure. A lot of question about curation, about validation, but still a very valid point. So now we'll hand over to, so don't forget to scan the QR code for the survey and fill the survey, of course, and I will hand it over to Paola for our final message.
Thank you very much, Lionel. Thank you very much to the speakers of this morning's sessions. We have witnessed a very, very, very rich morning of the ODOC 24. It's just the morning of the first day. So stay with energy, stay with us, because we still have a long ride for this afternoon. We are about to, immediately after lunch, we're going to have a unique session on uncrewed vehicles, UAVs. And please come along, because this is the first time in GEO we are addressing this type of data, which are more and more used across different applications, disaster, urban management, and we will learn all from our speakers. We'll follow with a session on youth and open knowledge. What is GEO going to do to empower youth and making sure that they are the ambassadors of open knowledge, and how we empower with open knowledge the youth community, universities engaging in university. I don't go in details. We have open knowledge and national GEOs, how national GEOs will be leveraging the tools like Geo Knowledge Hub and all the wealth of information we heard from the space, from In-Situ, and so forth. And we finalized the day with indigenous knowledge and open knowledge. So you see that the afternoon is still very exciting. Stay tuned, come on, engage, and continue the discussion. Now, I have a message before we break for lunch and we reconvene at 2:30 sharp, is that for participants who have already registered and they are ready to go on the technical tour offered by our Chinese host on the 27th, please do go to the reception desk and confirm again before 2 o'clock today. It will be appreciated for logistic reason, as you can imagine. And with this round of applause to all speakers and this is good.